Welcome to 7.5, parts of a similar triangle. Previously, we've learned that corresponding sides of similar polygons are proportional. And this was in 7.2. So we were able to define relationships between sides and solve for missing sides or the variable. What we're going to do is take this a step further, specifically with segments and triangles. And the first one's going to be the altitude. So the first theorem we have is if two triangles are similar, the lengths of corresponding altitudes are proportional to the lengths of corresponding sides. Meaning, AD is an altitude. Because these triangles are similar, AD is proportional to FJ. So when they set up their proportion, you can compare those two. AD is to FJ, and then they picked another segment to compare it to. So this gives us another opportunity to solve using proportions. In example 1A, we can see we have two similar triangles because we have angle Z is congruent to angle L, and angle X is congruent to angle K. So we know we have similar triangles. So setting up the sides, I can see that the side that has the 20 is proportional to the side that has the 15. And that's just based on the relationship between the two similar triangles. So my proportion is going to be 20 is to 15, and now I can use the altitude as well, as 16 is to X. If you like working with smaller numbers, you can reduce that, and I do, so I'm going to make it 4 to 3 is 16 to X. My stylus is not being cooperative. So moving up here, 48 equals 4X, so X equals 12. In this situation, we have X equals 12, and we can solve it this way because we know that if the triangles are similar, then the altitudes are proportional. All right, the next one. Corresponding angle bisectors are also helpful. If two triangles are similar, the lengths of the corresponding angle bisectors are proportional to the lengths of the corresponding sides. So in this situation, the angle bisectors are also going to be proportional. So we have LP is proportional to RT. What we also know is that QS and KP will be proportional, as will PM and TS. So when we're using the angle bisector, we can also use the segments across from the congruent angles to set up our proportions. Looking at this example here, we have, this is an angle bisector here, and I have 10 and 15 are both coming from the congruent angles. So 10 is to 15 and I know there's going to be a relationship between the angles that are congruent and the segments across from it. So 4 is to X. So going ahead and solving my proportion, I get 10X equals 60. We could have reduced that if you'd wanted to. Divide by 10, divide by 10. Oops. And now I get X equals 6. Our final one has to do with medians. Remembering a median goes from a vertex and bisects the opposite segment of the opposite side of the triangle. So if two triangles are similar, the lengths of the corresponding medians are proportional to the lengths of the corresponding sides. So in this example, CD is proportional to YZ, just as the sides would be proportional as well. So let's try applying that to this problem here. I have my median of 13 and my median of 9. So we have 13.5, excuse me, it's 13.5, is to 9 as X is to 3. So simplifying that, we get 9X equals 40.5. Divide by 9, divide by 9, and X equals 4.5. So we've seen 3 different ways to now set up new proportions to solve for corresponding sides. On the next page, I would like you to please try those four examples. So on this page, you're going to be able to try one of the 3 that we've learned previously, and we will review it in class. Thank you.